This is the first lecture for Math 261, beginning algebra. And we're going to use this textbook. It's from Blitzer, is Introductory Algebra for college students. We're going to use the 7th edition. And we're going to start today with chapter 1. So chapter 1 is on page 1. In your book, page 1, chapter 1 is about variables, real numbers, and mathematical models. So, and we're gonna start right away with section 1.1. Section 1.1 is Introduction to Algebra, variables, and mathematical models. So this is gonna be on page 2. So we're gonna start then talking a little bit about the new words, or maybe words that you already know, but we're going to try to understand the meaning, because this is crucial to understand math, that we understand the words that we use. So the first word that we're going to use is algebraic. Algebraic is just a word that indicates that when you use the word algebraic, that is indicating that you're going to use some letters. We're going to use letters to represent numbers. And algebraic also indicates that we're going to use some mathematical operation, like symbols like the plus sign, the minus, the multiplication, and the division symbols that indicate, or signs that indicate that we're going to perform some operations. So that's the meaning of algebraic. So in opposition to arithmetic, when you use the word arithmetic, that means that you only use numbers and mathematical symbols for operations, but you don't use letters. So when you say arithmetic, you use numbers only, but you still use these symbols. The symbol for addition, the symbol for subtraction, the symbol for multiplication, and the symbol for division, and others that we're going to be learning throughout the course. So we need to understand very, very careful the definition of algebraic expression and the definition of equation, algebraic equation. So when we say algebraic expression, what we are talking about is like a phrase in English. So we are talking about a phrase in English, meaning that there are no verbs involved. So an algebraic expression is just a collection of letters and numbers and operators. The operators are just these. These are our operators. And that's it. It's just a collection of letters and numbers and operator, but it's incomplete. There is an incomplete meaning, so it's like a phrase. So there is not a complete meaning yet. So, and then we're gonna have an algebraic equation. An algebraic equation is gonna mean, is gonna be equivalent to a sentence in English. So when you have a sentence in English, you have verbs involved. The verbs indicate actions. The verbs provide the full meaning that we needed to understand a statement. So, and again, algebraic is gonna indicate that we include variables and numbers in our statement. So you can check in your book on page 2 the definition of a variable, and they say that the variable is a letter, that represent a variety of different numbers. That represents a variety of different numbers. We usually use the last letters in the alphabet. So let's say the last letters in the alphabet are like, for example, U, B, W, X, Y, and Z. So the last letters in the alphabet are used. The last letters in the alphabet are used to represent that variety of different numbers. So we use the last letters in the alphabet to represent variables. So X is the common variable. So X can take any value. So you can say that X, you can have, for example, use a collection of numbers here. So I can have 1, 2, 3, and 4. And I can say that this variable X can take one of these 4 values. So the only values that are allowed for a variable, those values, that set of values is known as the domain of the variable. The domain of the variable. So if you have, sometimes we need to know the domain to understand what we're gonna do. So in this case, just think that the domain is just the values that you are allowed to use for that variable. So X again is a number. Even though you see a letter, it represents a number. So you're gonna be able to conduct mathematical operations with this letter in the same way that you learn to do it with numbers. So you can say 3 plus 4, there is a meaning for that expression. So you can say, for example, then 3 plus 4. So this is an algebraic, no, this is an arithmetic expression, 3 plus 4. If you say X plus 4, then this is going to be an algebraic expression. So you can see here only numbers, arithmetic expression. You can see here numbers and letters and operators, and that's an algebraic expression. But again, this is just incomplete. 3 plus 4, and then you say what? So we are missing a verb. So a verb is missing. So when you say 3 plus 4 equals to 7, then this is a sentence, right? This is a sentence. So you have full meaning. So this is an arithmetic equation, full meaning. So you can say X plus 4 equals to 7. That's another sentence. So there is a full meaning. So you say that when you add 4 to a variable, to a number that is not known yet, the answer is going to be 7. So it's a full sentence. So in this case, this is this is an algebraic equation. So what is the difference between an algebraic equation and algebraic expression? So this is the first concept that I need you to be very, very sure that you understand. The difference is the equal sign. So when you have the equal sign, you have an equation. So you have an algebraic expression on the left-hand side, on the left-hand side of the equation, left-hand side of the equation. Then you have the equal sign, and then you have another algebraic expression on the right hand side of the equation. So, and this is an equation, an algebraic equation. So left hand side equals right hand side. So this is an algebraic equation. So now we're going to start doing some operations with variables, with algebraic expressions, with equations later. So we're going to start just evaluating algebraic expressions. So this is going to be the next part of our lecture today. So we're going to be evaluating algebraic expression. So this is on page 2 of your book. So what do we mean by evaluating? It's just replacing a variable, with a given value, or expression, and simplify the result. So that's evaluating. It's going to be just changing the variable, replacing the variable with a number. And when you do that, you're going to end up with an arithmetic expression. And when we say simplify the result, what we mean by that is that the arithmetic expression should be reduced to its lowest or simplest way. So in other words, if you have an addition, then you perform the addition and get the result. If you have a multiplication, you do that, and so. So we're going to start with example 1. So example 1 is on page 3. So it says that we're going to evaluate each algebraic expression, for x equals 5. So we have our first expression to be evaluated is 3 plus 4x. So that's the first expression that we're going to evaluate. So this is an algebraic expression because there is no an equal sign anywhere here. So no equal sign, no equation, then this is an algebraic expression. We have an equation here, x equals 5. We're going to use this to evaluate this algebraic expression. So again, evaluating is replacing. So I'm going to write this here to be clear about what we're going to do now. So we're going to evaluate 3 plus 4x. We're going to evaluate 3 plus 4x for x equals 5. So what we're going to do is that we're going to replace every x in this expression with 5. So the first thing that you're going to notice now is that we don't use this symbol to indicate multiplication. So don't use this symbol, the x, to indicate multiplication. Why? Because we're gonna use X for a variable. So for a variable name, so we don't use then X to indicate multiplication. So this note is very important to have in mind. So use instead a dot, a central dot, parentheses, asterisk. So we can use those to indicate multiplication when you are working in algebra. And also when you have a number and a variable together, just by this proximity, that indicates also multiplication. So in this case, 4 is multiplying X. So let's continue with our problem. So I have 3 plus, then 4. 4 multiplies X. So, but X is going to be 5. So I'm going to use a parenthesis to indicate the multiplication process. And that's it. I'm not using equal signs here. I'm not going to use the equal sign, even though you're going to see the equal sign in your book. That's the source of many misunderstandings later. So the best way to proceed is that there is no equal sign here. This is an algebraic expression. So the way I'm going to indicate the process of evaluating is by using arrows. So with an arrow, I say that the previous step is given the second step or the current step. So in this case, I have an arithmetic expression now here. So I'm going to solve this. Remember, there are rules. The rules are that you multiply first. So you're gonna leave 3 plus, and you do multiplication first. You need to remember the rules in your previous classes about the order of operations. Order of operation. So you need to remember these rules. So the first one is exponentiation first. Parentheses, I forgot, that's the very first, parentheses, exponentiations, then you do multiplication and division, then you do addition and subtraction. So those are rules that you should know now. If you don't, then just remember. So here, you're gonna do first 4 times 5 is gonna be 20. And then you end up just by doing the addition. So you're gonna get 23, and 23 is the answer. So what we are saying is that 3 plus 4x, when you evaluate this algebraic expression for x equals 5, then this algebraic expression is equivalent to 23. So that's the thing. So you can see at the end, 3 plus 4x is going to be equal to 23 when x equals 5. Only at the end we conclude that we can say that these two algebraic expressions are equivalent, so they are equal. So that's the result. We have another evaluation to perform. You're going to evaluate 4 times x plus 3 for x equals 5. So that's the second part of the example. So again, evaluating means that we're gonna replace x with 5. So we're gonna write 4 times 5 plus 3. And then now we see that first we need to perform every operation that is enclosed in parentheses. So in this case, we're gonna work first the parentheses. So 5 plus 3 is gonna be 8. Then the final step is 4 times 8 is gonna be 32. So that's the result of evaluating this expression. So we can write that 4 times x plus 3 is gonna be equal to 32 when x equals 5. So we need to write the full sentence to understand what we were doing. So that's example 1. So I'm going to work on one more example, and then you're going to have your first list of problems to start solving as classwork. So classwork is going to be the way that you're going to start showing that you are doing your work. So yeah, let's work on example 2. Example 2 is on page 3. So example 2, page 3, it says evaluate each algebraic expression for x equals 6 and y equals 4. So now we have two variables. So the first one is 5x minus 3y. So that's the first one. So we're going to evaluate this for x equals 6 and y equals 4. So what we're going to do is just we're going to replace x with 6 and y with 4. That's what we're going to do. So we're going to write now the result of doing this substitution. So 5 times 6. So we need to understand that this is a multiplication. We need to understand that 5 is multiplying x. So that's the reason we're using parentheses, because if I don't use parentheses, you're gonna read here 56, and that's not correct. So 5 times 6 minus 3 times 4. So then we're gonna do multiplications first. So 5 times 6 is 30, and 3 times 4 is 12. And finally, you just do this subtraction and you're gonna get 18. So this is the final answer. And you can write 5x minus 3y equals 18 when x equals 6 and y equals 4. So let's work on the next part. So the next part is part B. So now we have 3x plus 5y plus 2 over 2x minus y, and we're going to evaluate. So we need to write here evaluate, and I needed to write here evaluate, otherwise the notes are incomplete. Evaluate this for x equals 6 and y equals 4. So what we're gonna do is we're gonna replace every x. So 3 times 6 plus 5 times y is 4 plus 2, and this is the numerator of a fraction. Then the denominator is 2 times 6 minus 4. So I replaced every x with 6 and every y with 4. Now I have an arithmetic expression. So this was an algebraic expression. Now this is an arithmetic expression. I just need to remember the order of operations. So I'm going to work the numerator first. 3 times 6, 18, plus 5 times 4 is 20, plus 2. So you leave additions and subtractions to the end, or to the last part. Unless they are enclosed in parentheses, then you proceed with that first. 2 times 6 is going to be 12 minus 4. So now let's simplify the numerator, and by simplifying we mean perform the indicated operation. So you need to use your calculator, or you need to use another piece of paper to do this operation. So 18 plus 20 is 38, plus 2 is going to be 40. 12 minus 4 is going to be 8. Then you proceed with the last operation. That's a division. 40 divided by 8 is going to be 5. So this is the final answer. So now you're going to start solving some exercises that are at the end of the section. So there are more material in this section, but we're going to work for some exercises. It's important for you to see that you are understanding this. So this is going to be 1.1 exercise set. On page 11, the directions are that you're going to evaluate each expression for x equals 4. So I recommend you to work the following exercises: 2, 4, 6, 8, 10, 12, and 14. But if you don't have enough time to work on those because you work or you have other activities to do, I'm going to ask you to work at least 2 of them, the most important ones. So you have here the book. You can take a screenshot. Then I'm going to write the ones that I need at least you to work, and including in the assignment that you're going to submit at the end of this lecture. So you're going to work 12, which is just 5 that multiplies x plus 3, and 14 is 5x plus 52 over 3x. So these two are important. So at least you're going to include in your final assignment for this lecture these 2 exercises. So I'm going to give you, you can pause the video now to work on those 2 exercises in a piece of paper, and we're going to continue in a minute. Now we're going to start working on equations. So equations are described on page 6 in your book. And we're going to determine whether a given number is a solution of an equation. So solutions of an equation are just values of the variable that make the equation a true statement. So we're going to evaluate the equation for the given number. We're going to simplify, and we need to verify that we get a true statement, because we said before that an equation is like a sentence, but a sentence can be false or the sentence can be true. So the equation is just a sentence, but we need to know whether the sentence is true or not. So when you get a false statement, then the number that you use to evaluate the equation is not a solution. So we're gonna start doing this by solving example 4. So example 4 is on page 6. So the directions are the following. We're gonna determine if the given number, is a solution of the equation. So we have the first part A, and you can just read from the book: 6x plus 16 equals 46. Then you have a semicolon, then the number 5. So the way that we interpret this exercise is that what is on the left of the semicolon, or the left of the semicolon, this is going to be the equation. This is the algebraic equation. And this is the possible solution. A possible solution. We don't know yet whether this is a solution or not. We only have this equation, then we have a number, and we need to know whether this number makes this statement, this sentence, to be true. So the way that we're gonna verify that is that we're gonna evaluate the equation for this number. So we're gonna write here that we're gonna evaluate 6x plus 16 equals 46 for x equals 5. That's the way that we're gonna verify whether 5 is a solution or not. So, and the rules are the same. So if you're gonna evaluate, it's just replacing every x that you have in the equation with 5. We only have one x, then you only have one substitution to do. So we're gonna have 6 times 5 plus 16 equals 46. Now you're gonna see why I was using the arrows before, because now I have the equal sign here. So I'm going to write every step, and then at the end I'm going to verify whether the final step indicates a true statement. So the left-hand side. The left-hand side is 6 times 5 is going to be 30 plus 16. The right-hand side is 46. So imagine that at this point, there is just a barrier here. So anything that is happening on the left-hand side has nothing to do with everything that is happening on the right-hand side. So I just need to simplify the left-hand side and simplify the right-hand side if I need it. And then at the end, I'm going to verify whether I get a true statement. So 30 plus 46 is going to be 30 plus 16, sorry, is going to be 46, and 46 is just 46. So in this case, you can see, wow, this is true. So this is a true statement. So that means that 5, x equals 5 is a solution, of the equation, 6x plus 16 equals 46. So this is the answer. Why? Because the final statement that we got from evaluating the equation is true. So now we have another part corresponding to example 4. Now we have another equation. We have 2 times z plus 1 equals 5 times z minus 2. Then we have semicolon, and then we have 7. So we read here that we have an algebraic equation, and then we have a possible solution, So we need to evaluate. So this is my equation, algebraic equation. So to solve this question about whether 7 is a solution or not of this equation, we need to evaluate the equation to z plus 1 equals 5, z minus 2, for z equals 7. So we're going to replace z with 7. So we have two z's to replace with 7. So we have 2 times, now z is going to become 7 plus 1, and this is going to be equal to 5 times 7 minus 2. 7. So again, we're going to work the left-hand side independently from the right-hand side. So let's work on the left-hand side. So we don't know whether this is true or not. We don't know yet. So that's what we're gonna verify. So we start with parentheses. So we have 2 times 7 plus 1 is gonna be 8. 2 times 8 is gonna be 16. So that's the value I'm going to get from the left-hand side. Now with the right-hand side, I'm going to multiply 5, and 7 minus 2 is gonna be 5. So 5 times 5 is gonna be 25. So you see your left-hand side, you see your right-hand side, you say that this is not equal to 25, or you say that 16 equals to 25 is false. So that means that z equals 7 is not a solution of the equation, and the equation is 2 times z plus 1 equals 5 times z minus 2. So 7 is not a solution. We're going to learn later how to find solutions of equations, but at this point, we need to learn first to identify solutions. So you have now more exercises to work on from the exercise set that is on page 11. So I'm going to give you again a couple of more exercises to work on. So let me write those on a different paper. So we have, again, this is 1.1 exercise set on page 11. 1.1 exercise set on page 11. So it's a lot of exercises. I understand if you don't have time to solve all of them, at least we're on the ones that I'm going to indicate. So I'm going to write the directions. So you're going to evaluate each expression. This is from the previous section. I'm going to write this for you. You're going to evaluate each expression for x equals 7 and y equals 5. So problem 20 is just 5x minus 4y. Problem 22 is just 50 over y minus 14 over x. And problem 24 with a star. So this is important that you include in your submission after the lecture ends. So this is the first part. Then the question. So you're gonna determine if the given number, is a solution of the equation. If you solve all of them, that's better. That's the best case scenario. But if you don't have time, remember you're gonna need to turn at least the one that have a star. So the first problem is x plus 17 equals 22, semicolon 5. You know that 5 is gonna be the possible solution. Then 48 is 5z equals 30, and the possible solution is 8. And 52, 3m plus 4 equals 19, possible solution for m, 6. And 56 is 4p plus 3 equals 6p, and the possible solution is 6. So one thing that I didn't say at the very beginning is that in algebra it's very important your handwriting. You need to write a handwriting that is clear, that is understandable, not just by you, by other people that are going to read your work. So I've seen many students fail this class just because of their handwriting, because they were, I don't know, in a rush to write equations. They use, try to simplify or to reduce the number of steps. Don't hesitate and write every single step. It doesn't matter that you're going to repeat the same thing again and just a minor change, but write every step that you follow when you are doing evaluation, and use a clean and clear handwriting. That's important to succeed. So you're going to have another break now, another pause. You're going to pause your video to solve these exercises, and then we're going to continue with the last part of the lecture corresponding to today. We're going to start now. Section 1.2 is on page 14 in your book, and it's about fractions in algebra. So we're going to need to remember our fraction method, the one that we learn in high school or middle school. So fractions is more about arithmetic operations. It's a division of two numbers. And it's important because we're going to use fractions later with variables, and when we incorporate variables, those fractions are going to be receiving a different name. So we're going to know those fractions as rational expressions. So anytime that you hear the word or the phrase rational expressions, they are talking about fractions with variables. So including variables. So a rational expression that we're going to learn in chapter 6 or 7 later is just fractions involving variables. So we need to remember our fraction math. So if you check page 18, you're going to see what reducing fraction means. So you have two fractions, and they are going to be equivalent if they represent the same value. How do you reduce a fraction? The way that you reduce a fraction is, the purpose of doing a reduction of a fraction is we need to find an equivalent fraction with the lowest terms. So we need the numerator and the denominator written with the lowest values as possible. To do that, we need to base our work on a fundamental principle of fractions that is also described on page 18. I just copied from that for your notes. So the value of a fraction does not change if both, and this is important, both the numerator and the denominator are divided or multiplied by the same non-zero value. So this principle is crucial for you to do your fraction math correctly. So in symbols, this is like saying that when you have A over B, so you can, for example, multiply the numerator by C, and you multiply the denominator by C. So you both multiply the numerator and the denominator. So the numerator is A in this case, the fraction bar, the denominator is B. So when you do this, you're gonna get AC over BC, and this fraction is equivalent to the original fraction. So that's the principle, and it applies on the other way too. So you can write now AC over BC, and now you want to simplify this fraction, and you see that these fractions, the numerator and the denominator, have a common factor. So C is a common factor. So when you have a common factor, you can divide the numerator by the common factor, which is C. You can divide the denominator by the common factor, which is C2. So you need to divide by the same number, and then you're gonna get A over B. So usually when you see is, when you have AC over BC, people tend to do the thing that you cancel the numerator, you cancel the denominator. That gives you A over B. So that's the fundamental principle of fractions. So we're gonna solve some examples. So we have example 4 on page 19. So we're gonna reduce each fraction to its lowest terms. So the first fraction is 6 over 14. So we need to find factors. We need to find a common factor for the numerator and the denominator. So what is that common factor? So factors are just numbers that, so you can break this 6 in 3 times 2. 6 is going to be 3 times 2. So you can call these two numbers factors. These are factors of 6 because you can break 6 in this product. Also 14 can be you can break it as 7 times 2. So again, 7 and 2 are factors of 14 because 14 can be broken into 7 times 2. And what is a common factor? You can see from these two factorizations that 2 is a common factor of 6 and 14. So 2 is a common factor. When you have a common factor, that means that you can divide the numerator and the denominator by that common factor. So I'm dividing 6 by 2, which is a common factor with 14, and 14 should be divided by 2 because that's the fundamental principle of fractions. You need to divide or multiply by the same number, both the numerator and the denominator. So if you do that, you're going to get, in this case, 3 over 7, and that's the final answer. So you can say that 16 over 14 is equivalent to 3 over 7. So these are equivalent fractions. Equivalent fractions because they represent the same quantity. So now we have another part of this example. So we're going to reduce 15 over 75. We're going to reduce, so meaning that you're going to go from a high number to a low number in both the numerator and the denominator. So that's reducing. So first you need to find, again, a common factor. So what is a common factor of 15 and 75? You can see that 5 is a common factor of 15 and 75. Then you're going to divide. I'm going to write this for your notes. You're going to divide both the numerator and the denominator by the common factor, in this case 5. So we're going to have 15 divided by 5, 75 divided by 5. So we're going to get 3 over 15. And we see that these two numbers also have a common factor. So now you know that 3 and 15, 3 is a common factor is 3 for both 3 and 15. So you're gonna divide by 3, both the numerator and the denominator. So at the end, you're gonna get 1/5. So 15 over 75 is equivalent to 3 over 15, and is equivalent to 1/5. And what is the fraction with the lowest terms? This is the fraction with the lowest terms. You can get this fraction, this intermediate fraction, in the exam, and you're gonna get the wrong answer because you need to go further. So you need to find the fraction with the lowest terms that are possible. So let me work 2 more problems from the same example. So we're gonna have now part C. We're gonna reduce 25 over 11. So you can check all your times tables, and then you're not going to find a way to represent this in a way that you're gonna get a common factor. So there are no, or there is no a common factor. Factor of 25 and 11. So the last part is 11 over 33. Again, you need to find a common factor. So the common factor in this case is going to be 11. So if you divide by 11, both the numerator and the denominator, you're going to get 1/3. So now it's your turn. You're going to work now on 1.2 exercise set on page 29. I suggest to work on all those problems for the assignment. So all are stars. 30, you're gonna reduce 8 over 14. So the directions are gonna be simplify each fraction by reducing it. To its lowest terms, to its lowest terms. So we have 30, 8 over 14, we have 32, 8 even over 45, we have 34 is 45 over 50, we have 38, 38 over 50, and finally 40 is just 116 over 86. And then we're going to have the last break before finishing this lecture. Okay, now we're going to multiply and divide fractions. That's the last part of this lecture. So to multiply fractions, which is described on page 19, we're going to simplify before multiplying. This is very, very important. You need to simplify before multiplying. What I mean by simplifying is that you're going to indicate the operation by using parentheses. And then you're going to see whether you can reduce the given, the resulting fraction. So for example, if you're going to multiply A over B, that's my first fraction, and C over D, that's my second fraction, the first step is just write the numerator as a product of the numerators, the original numerators, and write the denominator as the product of the original denominators. Then you're gonna inspect, you're gonna examine, and you're gonna look for common factors. You simplify, and only once you have finished the simplification part, then you proceed with the resulting operations. So let's work on an example. So we will have example 5 on page 20. So we're gonna multiply. So the first part of the exercise is 3/7, that's the first fraction. 2/5 is the second fraction. So what is the first step? The first step is just writing 3 times 2/7 times 5, and then we start looking for common factors between any part of the numerator with any part of the denominator. So we don't see any common factors, and we proceed with the final step, which is just performing the operation. So 3 times 2 is going to be 6. 7 times 5 is going to be 35. So nothing beyond that. So now we're going to work part B. And on part B, we have 5 that multiplies 7/12. So here you need to remember that any integer can be represented as a fraction by dividing that integer by 1. And then we have 7/12. Then we rewrite this by using parentheses. And then we look for common factors. There are no common factors, so we proceed with the multiplication. This is going to be 35/12. So for me, this is the final answer. The book shows you how to convert this improper fraction. This is an improper fraction into a mixed number. Into a mixed number. I'm not going to ask you to do that in this course, because for rational expressions, we don't do this operation. Rational expressions ends at this step. But yeah, if you do the conversion, something that you should know from previous courses of arithmetic, you're gonna get 2, that's the whole part of the mixed number, and then you get 11/12. So this is the mixed number, and this is the improper fraction. So that's the way that we're gonna do it. So finally, we have 2/3 multiplying 9/4. So again, we're gonna write this first using parentheses, 2 times 9 and 3 times 4, and then we're gonna start looking for common factors. Now you can see that 9 and 3 have a common factor, and 2 and 4, they also have a common factor. So let's do that. 2 can be divided by 2, and 4 can be divided by 2. So both the numerator and the denominator are divided by the same number. And also 9 can be divided by 3, and 3 can be divided by 3 too. So both the numerator and the denominator are divided by the same number. So let's simplify this. So 2 divided by 2 is going to be 1. 9 divided by 3 is going to be 3. 3 divided by 3 is going to be 1. And 4 divided by 2 is going to be 2. So then you just multiply, you're going to get 3/2. Again, this is an improper fraction that you can convert into a mixed number. I don't care about that. You just get me this answer, and you're going to pass this class. So we're going to finish with the division of fractions, and you're going to have these notes as a PDF file. You're going to find the PDF file next to the link to the lecture video on YouTube. So, and you are welcome to comment anything that you want to share with your classmates. We'll be grateful. So you can just post a comment on the comment sections for this YouTube video, and in that way you're gonna help other people learn, and in that way you are gonna show also that you have learned the material. So we're gonna end this first lecture by dividing fractions. So this is on page 20. So what is the procedure? You're just gonna convert the division into a multiplication. And then you proceed with the steps that we mentioned in the previous part. So we're gonna convert the division into a multiplication. So you have A over B, that's my first fraction, and we're gonna divide this fraction by the second fraction, which is C over D. So this is a division. We need to convert this division. The division is indicated by these symbols. This is a division of two fractions. Yeah, because in reality is more than one division. This is a division, this is another division, and this divided by this is another division. There are three divisions here, but when I say division of two fractions, I'm talking about this symbol here. So we're gonna convert this symbol into a multiplication symbol. So the division turns into multiplication. So what is the rule? You write the first fraction in the same way. So don't change anything, you write it in the same way. So, and you write the second fraction changing the numerator and the denominator. So you're gonna write now the denominator as numerator, and the numerator is gonna be now the denominator. So you're gonna interchange these two numbers. So you're gonna flip or swap the second fraction. So let's work on one final example. You get your classwork assignment and we finish the first lecture. So example 6 on page 21, you're gonna divide. Page 6, yeah, we're gonna divide. So we have, the first one is 2/3 are gonna be divided by 7 over 15. So first thing, remember, division should be converted into a multiplication of fractions. So we're gonna write the first fraction the same. We're gonna use now the symbol for multiplication, and then we're gonna swap or flip or invert or get the reciprocal of the second fraction. So those terms are equivalent. So finally, we need to check whether we have common factors. To do that, we write this in the way that we learned in the previous part of this section. So now common factors, 15 and 3, they have common factors. They have a common factor, is 3. So that means that you can write this as 2 times 5, and 3 divided by 3 is going to be 1 times 7. So 15 divided by 3 is 5. The other two numbers don't have any common factors, so we end this process by writing 10 over 7. Again, this is an improper fraction. You should convert it into a mixed number if you want to get the final answer that your book might have. Otherwise, that is the final answer for us, because when you use variables, converting into a mixed number has no meaning at all for us. So let's work. The second part is just 3/4 divided by 5. So first thing, we need to write the second part of this division as a fraction. So 5 should be written as 5 over 1. Now we can convert this into a multiplication. It's going to be 3 over 4. So the first fraction remains. The second fraction is flipped. So now we can just multiply this. 3 times 1, 4 times 5, no common factors. So the final answer is just 3/20. So it's time for you to work. I'm going to give you the final problems to solve. And again, it would be good if you can solve all of them. I'm not going to start any problem. I'm going to leave you. It's going to be up to you which ones you're going to solve. But yeah, this is 1.2 exercise set on page 29. And there are some multiplications, some divisions here that you're going to work on. So let's see. So problem 42 is 3/7 times 1/4. Then we have problem 48 is 1/8 times 2/3. Then we have problem 54, 7/8 divided by 2/3. Then we have problem 56, 12/7 divided by 3. Then we have problem 62, 7/4 divided by 3/8. And finally, problem 64 is 1/8 divided by 1/4. So this is your assignment. So there are many pieces that you have been collecting throughout this lecture. So you're gonna get just you're gonna take screenshots of your different pieces of work that you got from this lecture, the assignment, and then you're gonna convert all your screenshots in a single PDF file. How? You can just download and install an app. There are many apps to do this process. One app is Cam Scanner. Another app is PDF Scanner. And you can find many different apps where you can just take screenshots of every sheet of your work, and then you create a PDF file, and then you, again, you are in classwork 1A on Canvas, and then you just look for the submit button. And once you press this button, you're gonna be able to upload a PDF file with your results. I'm going to try to review your work as soon as possible. I'm going to give you feedback about your work, and then you're gonna have more lectures to go on this chapter. And for at the end of the chapter, you only have one single homework. There is one homework for the entire chapter. There is one quiz for the entire chapter. But there are many assignments, classwork assignments for the chapter. For chapter 1, you're gonna have 4 assignments. Classwork 1A, 1B, 1C, and 1D. So yeah, we're on this. Send me an email if you have any question. Or when you submit your classwork, when you do it, you can also have the opportunity to add some comments. You can just let me know whether you are struggling with one problem, and I'll try to answer that comment as soon as possible as well. So this is the end of the first lecture. I hope you're gonna like math, working with me. So yeah.